This is Chemistry Unit 4, Chemical Nomenclature. The language in chemistry is chemical nomenclature. Chemical nomenclature is a shorthand method used to name chemicals using element symbols and subscripts. Now, a subscript is a number written below the line, such as the 2 in H2. We use a binary system or two-part naming system similar to biology, and there are 3 ways to name chemicals. For ionic compounds, we have what's known as type 1 and type 2. So type 1 involves a metal with one form of a cation. Now remember, a cation is a positively charged ion. So metals are always cations, and they will be bonded with a non-metal or anion. So remember, ionic compounds involve a metal and a non-metal. And if it's type 1, that metal will only have one type of charge or one type of cation. Now, if it's type 2, this will involve a metal with 2 or more forms of cations. So a variety of charges for that metal, along with a nonmetal or the anion. So the difference between type 1 and type 2 is the versions of cations that you'll be able to use. And we'll label these on your periodic table in just a second. Now, molecular compounds are compounds that do not involve metals. They're simply nonmetals bonded together. So this is known as type 3. So it's between a nonmetal and a nonmetal, or just anions. And this type of naming is very different from that of type 1 and type 2. So we'll start with naming type 1, the ionic compounds. The first step is to name the metal. And this is usually from groups 1 or 2, which are the alkali or alkaline earth metals, along with zinc, aluminum, and silver. So you can see here in these examples, Na+1, this is sodium, that's an alkali metal. Mg+2, that's magnesium, that's an alkaline earth metal. And then we have the separate metals of aluminum, which is +3, zinc, which is +2, and silver, which is +1. Now, a great way to help yourself is to label your periodic table by the different types. So that's exactly what I'm going to show you here. So here we're going to label the type 1 metals. So we're going to start over here with our first 2 groups. So this lithium group, lithium down to francium, that is our alkali metal group. And next to it is Be down to Ra, so beryllium to radium. That's our alkaline earth metals. Now, what will also help is if you include the charges. So the lithium group, they all have a charge of +1. The beryllium group, they all have a charge of +2. Now, you'll notice that I did not include hydrogen in my labeling here because hydrogen is not a metal. It is placed above lithium because of its size, and it also has a +1 charge. So, but that also depends on the compound that it's in. So please be careful, do not include hydrogen in your type 1 naming. So do not include it in the labeling. But what you also want to include are those 3 separate metals, which happen to be over here. So here's aluminum, and it's +3. Here's zinc, and it's +2. And then here is silver, and it's +1. So these are all type 1. So you want to label that somewhere for yourself. These are your type 1 metals. Now, another good place to label are the anions that you will be using. The anions are over here, and 3 common groups that we'll use will be the nitrogen group, starts with N. And then right next to it, you have the oxygen group, starts with O. And then next to that, you have the group that starts with fluorine, which are actually your halogens. Now, these groups as well also have set charges. So it will help if you keep these labeled for yourself. So the nitrogen group, they're all -3. Your oxygen group are all -2. And then your halogens are all -1. So this will come in handy when you need to start naming your type 1 metals, along with their nonmetals. So let's start. how do you actually name your type 1 compounds? Well, if you're provided with a formula and asked to give the name, you start with the element that's written first, which is your metal. So Li is the metal, and if you look on your periodic table, Li is in this group 1 right here. It's an alkali, and the name is lithium. And yes, spelling counts because you will always have access to your periodic table. So make sure you are spelling it correctly. The second step is to name the nonmetal, and you will also make a change to the ending. It'll become IDE. So here's what I mean. If we keep looking at LiF, Li is lithium. Now F on the periodic table is fluorine, which is right over here. This is your anion or your nonmetal. So I know it's fluorine when it's on the table, but when it's part of an ionic compound, it is now named lithium fluoride. So only the nonmetal makes the name change to indicate that this is a compound and bonding has occurred. So let's keep practicing. What if we had NaCl? Na is over here, it is called sodium. Cl is over here, it's called chlorine when it's on the table, but now when you are naming this ionic compound, it becomes sodium chloride. Next one, MgBr2. So Mg is over here, it is called magnesium. Br is over here, it is called bromine. So this will become, as an ionic compound now, magnesium bromide. You ignore this 2 for type 1 compounds. Remember, they only have one type of cation, so there's no need to address that number. It'll be addressed in the type 2 naming. All right, one more. What about Zn3, N2? So Zn is not in these two groups, but it's over here, which we did highlight. So Zn is zinc, N is called nitrogen. So to show that this is an ionic compound, this is named zinc nitride. What if you are provided with the name of the compound and need to determine the formula? So we use what is simply known as a crisscross method. So I will try to get you to understand the reason for this crisscross method, but it will be further explained later on in the year when we talk in more detail about electrons and their movement and also bonding. All right, so if you are provided with the example cesium chloride, the first thing you need to do is find their symbols and their charges on the periodic table. So cesium is over here, it's right here, it's Cs, and it has a +1 charge. Chlorine is over here, chloride is coming from chlorine, so it's Cl, and it has a -1 charge. So first you write them down. So what this is telling you is that cesium can lose an electron and chlorine can gain an electron. Now cesium will only lose 1 electron and chlorine will only gain 1 electron. So this is a give and take, right, between the two elements. So one element will give its electron and one element will take its electron. So that's what this crisscross method is actually indicating. Now you don't actually have to draw this, but I just want to show you the give and take. Okay. Now what happens is that this becomes CsCl. You don't write positives or negatives in a formula, and you don't write the same number. This is 1 and 1, so that just cancels out. In fact, you never write ones in formulas, but here we have both elements have a 1, so they simply cancel out. So this means that one element gave an electron and one element took an electron. So it's an even exchange. All right, let's try another one. What about aluminum fluoride? So the first thing you need to do is find them. So here's aluminum, it's Al, it has a +3 charge. Fluoride is coming from fluorine, and it has a -1 charge. So the first thing to do is write them down. So aluminum +3, Al +3, and fluorine, or coming from fluoride, is F -1. So what this means is that fluorine can gain an electron. Aluminum can give 3 electrons. So if aluminum wants to give 3 electrons, those electrons need to go somewhere. So if the bonding is going to occur between aluminum and fluorine, fluorine doesn't have enough ability to accept 3 electrons. It can only accept 1 electron. So in order to make this neutral, to make this be an even exchange, you would need 3 fluorines to make this happen. But instead of trying to explain that or show that visually, what's really happening is this crisscross method. So when they exchange, this 3 will go to fluorine and the 1 will go to aluminum. So what really happened here is aluminum gave its 1 aluminum gave away its 3 electrons to 3 fluorines. So 3 fluorines accepted those electrons. But just to make this faster, we call this the crisscross method. So aluminum moves its 3 to fluorine, fluorine moves its 1 to aluminum, the 1 is not shown, and your pluses and your minuses are not shown. Okay, let's try one more. What about calcium oxide? So calcium is over here, it's Ca, has a +2 charge. Oxide is coming from oxygen, and it has a -2 charge. So the first thing to do is to write these down. So calcium is +2, so it can give away 2 electrons. Oxygen is -2, so it can accept 2 electrons. And you can tell here now that the charges are even, so this is going to be an even exchange. So if calcium can give away 2 electrons, it needs 2 elements to accept those, or 1 element with the ability to accept 2 electrons at the same time, which is oxygen. So that -2 means that it can accept both of calcium's electrons. So this is an even exchange. The 2's cancel, the pluses and the minuses cancel. So this is type 1 naming.